Hello, my name is Vadim, and this is an introduction for SoTeSoLa Hackathon on reverse engineering and re-engineering. It takes place as a part of the SoTeSoLa summer school. It's a summer school on software technologies and software languages. This introduction is mostly meant for remote participants because the on-site participants will get a live performance of the same thing. So, what is SoTeSoLa? It's software technologies and software languages. By software technology, we mean something like, for example, in modeling, something like UML, something like EMF in Eclipse, QVT, or mega modeling things. For mapping, you can have OR mappings like ODB or maybe Hibernate. You can have also XO mappings like JAXB or Xstream. But Xstream can also go from objects to text. So it's also should be compared or at least named in the same list as JSON, YAML, and so forth. There are many software technologies for graphics, for build automation, for web programming, and for many things that we use in software development. So software languages, the second part of SoTeSoLa, is really about a language in which you write your program and store it. So it can be something very simple like Java or C#, Scala, Groovy. It can be Haskell. It's something even simpler, a Haskell or a Haskell dialect, or COBOL, and even COBOL dialects. It can be some dynamically typed languages for hacking like Python, Ruby, Perl, basically anything with regular expressions qualifies. It can be some web programming languages, Lisps, OCaml, and whatever you want to write your programs in. So the third notion that we'll introduce is a software Chrestomathy. So you probably have heard something about Rosetta Code. Rosetta Code is a programming Chrestomathy. So it's task-oriented. There are 450 programming tasks and a lot of implementations, solutions to those tasks, and they cover more than 300 different programming languages. So one company is another Chrestomathy, and it's a software Chrestomathy. So it's more oriented on problem domain, which is a human resource management system, and it's more small system oriented. So it covers the use of software languages, but also software technologies, which is why it is the focus of the SoTeSoLa Summer School. So it has a bit more than 100 implementations, which cover quite a big number of languages and technologies, and they're all very precisely documented and stored in elaborate detail. So the objective of our hackathon is to exercise methods and tools for reverse engineering and for re-engineering by applying them to one-on-one company's repository. So on the right you see some examples of things that anyone can use, or things that people will present at our summer school. But it's a very open-ended list, so you can add 100 more things, and basically you need to add your favorite thing there. The expectation of this hackathon is to produce a corpus of samples used for teaching reverse engineering and re-engineering. So the rules for the hackathon is, here's a link, you need to register. If you haven't done so, please do. There will be Hangouts on Google, sessions on Skype, there will be on-site sessions as well. The on-site participants will get a free pizza, otherwise you get a picture of a pizza. You need to propose your problem yourself, so we don't define precisely what you need to do. You have to come up with that yourself. You develop your solution and you commit your code to GitHub. We help you with that, so on site there are 3 people specifically dedicated to coordinating and helping with the hackathon. And well, if you're a remote participant, you can also send us email or tweet us, or do anything to ensure that you are that you come up with a good idea, that you develop something that is feasible, and that you commit it somewhere. You can do it in your own repository. You can fork the SoTeSoLa thing. Well, do whatever you usually do with software repositories. And there is a prize, you can win it, and if you win it, you have to utilize it somehow. But that's up to you. So the details of a hackathon, usually on-site participants will be working in a team of 3 people. So for remote participants, it's not an issue, but it is a metric of complexity. So we think that it's a reasonable thing for 3 people to do and to not be completely bored, but also not to exhaust themselves. So you bring your own favorite methods, tools, your expertise in them, and so forth. We give you the data. The data is the Chrestomathy, the software Chrestomathy of one-on-one companies. You think of a problem, you choose an appropriate subset of implementations, so most probably your solution will not work on all the implementations, but you can have a reasonably defined subset of them and have your solution work on them. And well, you need to hack it. So the hackathon is focused on reverse engineering and re-engineering, where reverse engineering is obviously the foundation for the re-engineering efforts. So for reverse engineering, you can do something like fact extraction. So size metrics like lines of code, McCabe complexity, maintainability index, Halstead thing, but it doesn't have to be metrics. It can be something like dead code detection, for example. You can also go for software visualization, like control flow, data flow graphs. You can visualize metrics, but you can also visualize like relations between entities in a system. You can also do vocabulary mining, so extract the names of the entities from a solution, and then do some analysis on them, like, I don't know, identify verbs, nouns, draw word clouds, and compare it to some existing ontology, for example, and by comparison, verify that ontology. You can also analyze the technology used. So if an implementation claims to use a language, how extensively is it used? If you have a technology, then what features of that technology are the most used ones? Which functionality of a software technology or software language is never used among any implementations? If you use an API, what's the coverage of its use? You can also recover some architectural details, like, for example, get a UML model or whatever model you want from the source code. You can do inference of data models or grammars in a broad sense. You can do grammar recovery. Design pattern recovery is also possible if you want to kind of analyze the program code to discover something that could have been a pattern. Okay, so re-engineering is kind of, we think of it as the next step, but obviously you can either do only reverse engineering if you are not a fan of re-engineering, or you can, you can compromise. So you can do something extremely simple like refactoring. You apply known refactorings to existing solutions. Obviously, you know that even the standard refactorings that are built in Eclipse, they don't always work. Some generics and some reflection might break it. But basically, you want to make something that doesn't break. Well, at least you want to claim it. We've talked about dead code detection in the reverse engineering part. In the re-engineering one, you can think of dead code elimination. You can also try to refactor transform your source code in order to migrate to a different API. But if we're talking about migration, you can also do it differently, like with wrapping the same API migration, or with, I don't know, some external components. So you can migrate to or from an API, a language, a framework, a platform, whatever. You can also think about code injection, like you have a code, you have some source code, you have some program, and then you inject assertions. You can inject logging capabilities. And you can also do something in the lines of aspect weaving or feature composition if you have a framework or if you want to develop something for that. Architectural modifications is also a big thing. Anything that constitutes an architecture, like components, I don't know, API. So we've analyzed in the reverse engineering part, we've analyzed how API is used. How can we improve it based on that knowledge? That would be an architectural modification. Legacy system renovation. So I'm not sure 101 companies has genuine legacy systems, but you can claim that, you know, JBoss is very yesterday, so we need to obviously get rid of it and, you know, redo the same implementation within a different framework. That would be a migration or renovation thing. So let us remind ourselves about the objective of a hackathon. Again, we have methods and tools for reverse engineering and re-engineering. It's your tools, your favorite tools that you use to apply reverse engineering and re-engineering techniques to the repository of 101 companies. And the expectation is to produce a corpus of samples for teaching reverse engineering, software mining, re-engineering, and related subjects. Okay, happy hacking!